Hi, Nitin sir. I've made you the host, so you can start in a few minutes.
Okay, ma'am. Thank you.
Thank you.
Okay, we'll start off. Fine. So today we are basically discussing you aren't audible. I just started speaking. Am I audible now? Okay, so basically now what we are supposed to discuss is today we had done previously class, we were doing mechanics, which was related to your kinematics portion, which is related to your motion. Now we'll be discussing more about the properties of matter. Now, when you're discussing about properties of matter, the first thing which you're supposed to know is stress. In general, what we write stress as, stress is written as force upon area. Okay. If I'm writing force upon area, what is a stress? If I just want to define a stress, the definition part, obviously it is not needed, but for your concept part, stress is basically now what you're trying to do is, like, there is a body. On that body, you're trying to put some force. If you're trying to put a force on this body will put an opposite force. Okay, that is known as F restoring force. It will not allow to put force on itself, and this restoring force, while it is putting that restoring force, there's an amount of stress, or there will be amount of some changes in the body will be developed in regarding to the internal forces. Okay, this is basically F restoring force is being provided internally from the body. Okay, F restoring force. So this restoring force is acting on which area of the body? That is what is stress is defined as. So if I just want to specify what is stress, so force, or this force is which kind of force? Restoring force. In general, why we don't write restoring force? Because we assume that system is in equilibrium. When the system is in equilibrium, so the force which is externally applied, this force which is being externally applied, will be equal to F restoring. So that's why we don't write in the formula anywhere. You'll see they don't write it as F restoring or F external. This is written upon force upon area. So that is a definition for stress, the restoring force which is set up inside the body when there is something, or there is some external forces being applied on it. Okay, so when I'm talking about the equilibrium position, F external will be equal to F restoring. What will be the SI unit for this? SI unit for this will become Newton per meter square, which is equivalent to your unit of pressure, which is nothing but Pascal. So they can also ask you in the terms of dimension, in terms of units, mostly in terms of dimension, that which among the following have the same dimension as pressure. So stress have the same kind of units which pressure have. Now when I'm talking about types of stress, we have types of stress. The first type of stress is known as normal stress. Normal stress is in general whatever we see, like this condition, this is known as normal stress. Why I'm saying this is like, see, this is a body. On the body, if the force is acting normally on it, if the force is acting in normally on this external force, so restoring force also will be in that same direction. So at this point only the restoring force and external force both will be acting. So when the stress is being applied, or when the stress formation is there on the surface normally, so that is what is known as your normal stress. It can be from this side also, it can. So this is which area I have to afford to take here. Like if this area the force is being applied, so I have to take this area at this calculation. I can have a situation that here all they have given you the area. Here on this side they have say this is a cuboid, and this is a top view of a cuboid, and this area is 4 meter square, and this area is say 6 meter square, and they're telling you to find out the stress on when the force is applied on this surface area. So for this case, what I have to calculate, I'll calculate force is equal to, sorry, I'll calculate stress is equal to, stress is denoted by sigma normally. So stress is force upon area. So which force I'll take, whatever force is being applied, so 10 Newton force is applied or 12 Newton force is being applied. So I'll write it as the force is equal to 12 Newton on which area it is being applied, this area. So if this is 6, this is also 6. So I'll just write this as 6 meter square, which will give me 2 Newton per meter square. So you have to be very thorough when you are applying which area is there. Now, when in the same condition, say now what I am saying is, if say in terms of a book I am saying, what I am doing is, I am applying a force tangentially to the surface. If I am applying the force tangentially to the surface, what will happen that there will be a movement of the only the upper. This part is say fixed, or they say that this part is hinged. This is not moving. Only this will move. So what will happen? The top surface will move a bit, it will get deformed from its original position, and it will occupy this space. So this is what I'm trying to do is, here I'm trying to apply force tangentially. So this kind of force where we are applying the force tangentially, we say that this gives you rise to the next kind of force, which is known as tangential stress or shearing stress. Okay, which is shearing stress or tangential stress. Like this only, when I'm talking about something is present inside the water, it will develop volumetric stress. Okay, that will lead to the formation of volumetric stress. Now when I say I'm talking about tangentially, so say if this is, there will be a difference. If this is theta, this is force, so this will be L, this will be X. So this and all will, that when I'm talking about the calculation, we are trying to calculate it. Okay, so this is basic definitions, and I'm talking about stress. Parallel to stress only, there will be a component. Wherever there will be stress, there will be a next component which is known as strain. So when I'm talking about stress, I will have something known as strain. Okay, strain is nothing but strain is defined as what? Change in dimension by original dimension. When I'm trying to define the strain, strain is defined as change in dimension, change in dimension upon original dimension. So change in dimension can be in any case. It can be like in terms of length, in terms of volume, in terms of area, in any possibilities there, because I'm writing dimension, I'm not specifying which dimension. So I can have, again, when I'm talking about strain, what will be the unit of strain? It will be a unitless quantity, because I'm dividing with dimension by dimension. If I'm taking on the top length, on the bottom also length, top meter square, so bottom also meter. So it's a unitless quantity, it's a dimensionless quantity. Okay, it's a unitless quantity, it's a dimensionless quantity. Now say if there is a case, like say if I'm talking about stress also, if there is a long body, on this I'm applying a force F in this direction, and then if I'm trying to apply F of this direction as well, and say if the length here is L, so what will happen is, if this is more, there will be a change in dimension in this direction, or if this is more, there will be a change in direction in this motion. So now what is change in dimension? So say I'm assuming this to be X, if I'm assuming this force is there. So now previous dimension was what? L. Now original dimension, I'll write it as delta L. So what will be there? Change in dimension will become delta L upon original dimension is L. So this is what kind of strain? This is longitudinal strain. So it's like that's only when I have normal stress or longitudinal stress, both are same. Normal stress can also be named as longitudinal stress. So longitudinal stress will be there, so longitudinal strain will be there. Shearing stress will be there, so shearing strain will be there. Volumetric stress will be there, then volumetric strain will be there. So for all the skills, we have certain things to define. So what is basically important in this is, when we are trying to define what is basically important here is, we have a term which is known as, which is the first law which is very important, is Hooke's law. Hooke's law says what is within elastic limit. We write what? Within elastic, within elastic limit. Okay, within elastic limits, stress is proportional to strain. Within elastic limit, stress is proportional to strain. So if I'm trying to switch on, I'm trying to remove the proportionality constant. So it will be what? Stress is equal to E times strain. Where what we write E as, E is written as what? E is equal to coefficient of elasticity. Okay, coefficient of elasticity. So this is basically when I am trying to define what. Now what is important is, the most important thing for you is this graph, where you have to understand that what is which kind of reason. Now when I'm trying to draw it, when I'm trying to find out, when I say this is graph being drawn in between what? Stress and strain. On this side if I'm taking stress, and this side if I'm taking strain. So if I'm trying to define this, what we have defined for our Hooke's law. Hooke's law says what? Stress is proportional to strain within this elastic limit. So when you see the straight line, so you can understand that at this region from O to A, what is being followed is Hooke's law is being followed, which is what? Stress is proportional to strain here. Now when stress is proportional to strain, so this is what is the elastic limit. Now what basically elastic limit means? Elastic limit means that position where, when a body is stretched to Till that limit, if you release the force from the body, it will again retain back its original position. So that is what is known as elasticity. Elasticity is a property, and elastic limit is that property from where sound is not clear. Sound is not clear. Is sound not audible? Okay, I'll try to speak louder. Okay. Now, what is there is when I'm talking about stress versus strain graph, this is a point up to where you'll find out that stress is being proportional to strain. So up to from this particular reason, what is being followed? Hooke's law is being followed. Further to this, what will happen? There will be increase in strain still. So what will happen here is up to this position when you try to, so this is known as, this region is particularly known as, if I want to define this region, this will be known as what? Elastic region. Okay, and when I'm talking now, what happens further? You keep on increasing what? You keep on increasing the force. You're increasing the force, you're trying to put more stress on that. So what will happen? You can see there is a small increase in the stress, but strain keeps on increasing. After reaching to some point, there will be not much increase in the strain. There will be a sudden increase in the stress. So this will be the point where now the thing which I have taken will start yielding. What yielding basically means that now it is not going to return back to its original position from where it have been stretched to. So once it reaches to this position, it's not possible to retain back the original position. Still up to here, if it is, there is chances, if you release, the body will again attain its original position. But now what will happen is later when you're moving further after C, what will happen is it will start breaking. Breaking means it is not full, have it's not broken full, but it is ready to break now, because what will happen, for small increase of stress, there will be a huge increase in the strain portion. And at this position, after reaching to this point is known as breaking point. The reaching to this point, the particular thing, or the particular element, or the particular material you are using, it will break. So this point is known as breaking point. So you should know which is breaking point, which is yielding point. Yielding point will be that situation where for a small stress application, there will be a huge increase in the strain. So that's how we define when I'm talking about stress and strain curve. Okay. 1 minute. Okay. So now we'll go to the next thing. Fine. So the next thing which we are supposed to read it, as we defined that E is equal to, if I'm talking about, then I'm saying I just now defined that E is equal to what's the coefficient of elasticity. So E is equal to stress by strain. Now, when I'm trying to draw, I'm writing, so there will be type of coefficient of elasticity. The first type of coefficient of elasticity is what? It is Young's modulus, and Young's modulus is defined as longitudinal stress, longitudinal stress, longitudinal stress, and upon longitudinal strain. This is how we define the Young's modulus. Now, if I'm trying to write the formula for longitudinal stress is defined as, now it is equal to, so I have longitudinal stress as what? Force upon, the force upon area is longitudinal stress, and longitudinal stress is defined as, strain is defined as delta L upon L. That is what? Change in length upon original length. So if I'm writing Young's modulus, the ratio of Young's modulus is longitudinal stress by longitudinal strain. Longitudinal stress is F upon A. Longitudinal strain is delta L upon A. So F by A, if I'm trying to write it, it will become what? F times L upon A into delta L. So that will be the definition when I'm trying to define the Young's modulus. The next coefficient of elasticity is known as, this is known as what? This is known as Young's modulus. This is known as Young's modulus of elasticity. Now, second one, what we have is, this is known as what? B, which is known as bulk modulus of elasticity. This is known as bulk modulus of elasticity. Normally, this Y is denoted only for, it is only used for one dimension. When I'm using bulk modulus is used for 3 dimension. If I'm trying to define bulk modulus, it is defined by volumetric stress. If I'm trying to define bulk modulus, it is volumetric stress upon volumetric strain. If I'm trying to define volumetric bulk modulus, it will be volumetric stress by volumetric strain. Now, when I'm talking about volumetric stress, still it will be force upon area. Now, what is basically I'm talking about when I'm talking about volumetric stresses? Say you have a body which is inside liquid. So I have a body which is inside a liquid, say may be water. So this will be starting putting force on this particular thing, on this particular substance. So what will happen? There will be a change in dimension over here because of this force. So force will be being applied on this particular area. So that time I'll write volumetric stresses del F by A. Now in this case, what I'll write, there will be a change in volume. So I'll write it as delta V by V. And I write a negative sign here. Why I write a negative sign here? See, when I'm talking about change in dimension, you can see that the change when the initial dimension, when initial volume and final volume, we are trying to find out final minus initial. This will give you a positive value, but I need to find out what final minus initial. So final is what? V2 minus V1. You can see that V2 will be smaller then compared to V1. So this will give you a negative answer. So to counterattack this negative answer, we try to put negative sign here. That is one reason. Second reason is because the force is being applied against the body, is trying to come out, is trying to increase its volume, but the volume of the body is being decreased. So because of that also the negative sign come here. So this is what is bulk modulus, which is basically defined for three-dimensional thing. Now when I'm talking about your third kind of dimension, the third kind of modulus of elasticity is known as what? Shear modulus. And I'm talking about shear modulus is defined as, and I'm talking about shear modulus. So shear modulus is, see, many books shear modulus, they write it as G, or they denote it with K. K is nothing but kappa. So you define it with anything, no problem. Okay. So when I'm talking about G, the shear modulus is defined as, it is a many book denoted as eta as well. So you can see anything is there, but you have to know that whenever there will be a tangential stress or there will be a shearing stress, so we have to use the formula for shear modulus. So shear modulus is basically is equal to shearing stress. So shearing stress upon shearing strain. Shearing stress or tangential stress, both are same thing. Okay. One more thing here, we have one more term which can be defined here is its compressibility. Now when I'm talking about compressibility is defined as reciprocal of bulk modulus. This is important. I'm saying that compressibility is a thing which there is a property of a particular liquid. So compressibility is defined as reciprocal of bulk modulus. Shear modulus is shear stress by shearing strain or tangential stress by tangential strain. This is usually used for two-dimensional geometry. That is what we are supposed to define. And say if I am trying to say here, if I'm trying to define this, so there will be a force upon that area, and then there will be some, say there is some shearing strain which is denoted by phi. That phi will depend on the different body, how the body is behaving to the different force. Okay. Now when I'm done with this thing, we have a small term which is supposed to be defined here as Poisson's ratio. There's a small term which is supposed to be defined as Poisson's ratio. Now what is this Poisson's ratio? Is, say I have a body which have a radius of something like, say, cylinder, and now what is happening here is because of the application of force, there will be a change in dimension in this side also, and there will be a change in dimension in this way also. So when there is a change in dimension of both the things, we have a thing which is being defined here is Poisson's ratio. Poisson's ratio is denoted by sigma, which is written as lateral. It is ratio of lateral strain. It is lateral strain upon longitudinal strain. It is latent strain upon longitudinal strain. So you can see that it is ratio of strain to strain. Again, when you have similar kind of quantity, so what that dimension of this will become, it is unitless quantity. If something is unitless, obviously that is going to become dimensionless also. So we already have two datas here which are unitless and dimensionless. One is strain, other one is Poisson's ratio. We are supposed to remember the value for this. So the Poisson ratio value is equal to this much. When I'm talking about this is theoretically. Theoretically, when we try to find our value of Poisson ratio, it comes to this thing. It is greater to -1 and lesser than 0.5. And when I'm talking about practical values, when we have done experimental values, that is, this is greater than 0 and lesser than, it is greater than 0 and lesser than 0.5. That is how we define this. So this is what is Poisson's ratio. Using this, we have to write some relations between which we have done now, 3 modulus of elasticity and Poisson's ratio. So when you're trying to write this, so this is gamma is Young's modulus, 3 times B is your bulk modulus, bracket is 1 minus 2 sigma. Sigma is nothing but Poisson's ratio here. When I'm defining, this is the first relation. The second relation here is, you can write Y is, that is Young's modulus is twice of G in bracket 1 plus sigma. Again, further, if I'm trying to define the other relations between them, the third relation is sigma is equal to 3 times bulk modulus minus 2 times of G upon I have 2 times G plus 6 times B. Now the fourth value which we have to, this is just a relation to interrelate what all the modulus of elasticity and Poisson's ratio. This is the fourth relation we have. So this is basically the when I'm trying to define about what we am trying to define about stress, I'm trying to define about strain, I'm trying to define about the stress strain curve. So stress is what? It is force upon area, which force? Restoring force on whichever area it is acting. Strain is change in dimension upon original dimension. Then you have to know that which is elastic limit, which is plastic region, and what is breaking stress, what is yielding stress. And then we try to define what is Poisson's ratio. And then we have the ratio for all this. So you have to remember this much minimum for this. The next part in this, what comes is, you have one part, the next topic is work done. Next topic is work done, or we say it as potential energy in a stretched wire. Say if you're stretching a wire, so what is the work done in stretching that wire, or whatever you stretch, right? For that, restoring force will be acting. It will try to avoid that change in it. So that is again known as what? But that particular energy will be stored in the form of potential energy in the string. So what happens when a wire is stretched? We are trying to do work on it, and there will be a work done against that particular stretching force, which will be done by the interatomic forces or intermolecular forces. And this particular work done will be stored in the form of potential energy, which is defined as potential. And this is defined as what? It is half times load times extension, half time load time extension. So what will be the extension? That extension will be taken as your this thing. And then further, if I'm trying to find out load will be what? Force, that is what is being applied on it. And extension, because of that, how much extension will happen, that is. And this can also be written in this form, that it is equal to half time stress times strain times volume. So we write it as stress times strain times volume, which is sometimes they ask you that what is potential energy per unit volume. So potential energy per unit volume can be written as half stress times strain, or it can be also written, if I substitute the value of strain over here, I can write it as gamma times strain whole square. This is very important, this terms. This I have just substituted the value of strain over here. If I'm trying to substitute stress by, I know that gamma is equal to stress by strain. So using this, I have substituted stress is equal to y times strain to get this one. So this is what? This is potential energy. This is potential energy per unit, potential energy per unit volume, this one. And this further is obviously this, okay? Fine. Next. Okay, next thing is what we have to define is, say we have a liquid surface. I have a liquid surface over here. So what will happen here, this liquid free surface, there will be a inside, whenever we say, like say here we now talking about some particle which is present here. So on every dimension, it will have, on every direction, if you try to find out, it will have equal forces on every dimension or in every direction. But when I'm talking about the particles which are present on the surface, which it comes on the contact of air as well as water. So because of this, what happens, there will be a different force here and there will be a different force here. There will be a different force on this side, there will be a different force on side. Basically what it will lead to, it will be leading to a cohesive type of force. So this is a cohesive forces which is acting on the surface of the liquid. So why it is happening? Because you have two different kind of molecules present over there. You have the molecules of water as well as you have the molecules of air. So because of this, there will be a small tension developed on the surface of this kind of particles. So we try to denote it with S, which is known as surface tension, or you can try to, many books denote it as T as well. So if I'm trying to write it as T, surface tension, or you can define it as S also. So it will be refined as what? Force per unit length. This is how you try to define surface tension. So surface tension is nothing but it is defined as force per unit length. It have arisen. Why? It have arisen because of cohesive forces. Cohesive forces are what? Because whenever you have two layers or two kind of molecules, that is known as cohesive surface, and there only there will be a rising cohesive forces. So cohesive forces, because of that, there will be a difference in the net force, and because of that net force, there will be a tension arose on that particular surface. That is known as force per unit length. Now, whenever there will be a force, there will be a tension. So what will happen is, to avoid this tension, the particles which are present there, they'll be doing some work done. There'll be a work done against the force of, what it will be done was work done against the force of surface tension. When you are trying to do work against the force of surface tension, so this particular thing is known as what? Surface energy. So this is the term which is defined for whenever there will be a surface tension. So what will happen there? I'm supposed to do work done against the force of surface tension, which is being formed on the liquid surface. And this is known as what? Surface energy. So work done has to be done to avoid the surface tension. That is known. Now, what will be the unit of surface tension? Unit of surface tension will be Newton per meter. If I'm trying to write dimension, it will be what? MLT minus 2 upon L. So it will lead to MT minus 2. So dimensions of all these values you are supposed to know, whichever physical quantity you come across while you are studying total physics. Okay. So next topic, if we are going to the next topic is capillarity. Now, what is this capillarity? So say what we have done is, in some test tube or in some tube, what I have done is I took some liquid. So what is the chances is that particular liquid, say you dipped it somewhere and this is where the liquid is filled. You can see that the liquid can get filled up to certain level, Okay, and it can form a surface here in this way, which is known as concave. This is known as convex, and this concave, the surface name is known as meniscus. So meniscus is what? It can be concave type or convex type. Concave is mostly for the water and all the which have a low density liquids. They'll form concave meniscus, and high density liquids like mercury and all, they'll try to form a convex kind of meniscus. So what happens if I'm assuming that it is forming a surface like this? So there it will be forming some angle theta at this position. So for this, and the liquid will come to certain level. It will not cross to a full like full tube will not get filled or certain. So to calculate that thing, that how much height the liquid goes into that particular tube. So we define it as what? Capillarity is basically what, if I'm trying to define it, it's a phenomena. Capillarity is basically phenomena of rise or fall. It can be rising also, it can be falling also, of liquid in a special kind of tube, which is of liquid in capillary tube. Okay, so this is what and we have a formula for this, which is defined as H is equal to 2 times T cos theta or S cos theta, whatever you want to write, rho R rho G, where R is what? When I'm trying to write a T will be surface tension. T is your surface tension. Then theta is what? Theta is the angle of contact. Angle of contact where there is a contact between the surface of the tube and water. So that is known as what? Angle of contact. Now for next, R is written as what? R is this is radius of R is radius of tube, whereas the what is it? Rho is density of liquid. So this is how the capillarity thing is defined. Okay. So this is the surface tension, then angle of contact, radius of tube. Height is what? Basically this height. Height is, so how much height the liquid within the capillary tube will go. It can go up and down. Depending on that, we have to find out. H theta will be given in that way if it is in this direction or that direction. According to that, we have to calculate if it will be 0 degree or 90 degree or 180 degree, depending on the question. When you're solving question, while solving question, you can become more clear about this. Okay, fine. So this is still now what we have discussed is stress, strain. Then we went to other things, it is finding out modulus of elasticity, modulus of rigidity, bulk modulus. Then we came to the stress strain curve, and then we defined the fifth last property. Okay, now what we have to discuss is whatever we were discussing up to here is basically relating to somewhere those materials which have elasticity, somewhere with materials have liquid fluidity, or they have. So whatever we studied till now was fluid static, when the fluid is not having any motion. So that is known as what? Static fluids. But there are so many liquids which will be having motion. They will be under dynamic. Like say if you have kept particular kind of utensil, if you have kept a water filled in the car and the car is moving, you see if you put certain brake, there you can see there's certain kind of splashing inside the bottle. So that thing is what? Basically that particular thing, that particular liquid is undergoing the motion. So for that thing, obviously the first formula, irrespective of anything, is known as, I have was what? Pressure is equal to force upon area. The unit is Newton per meter square, which is also written commonly as Pascal. Okay, so to define the motion of this kind of liquids, we have certain law. The first law which we came across is Pascal's law. So Pascal law says what is, if you have a liquid, so if the liquid is going to apply the same kind of force in every position, and say what you have done is, what you did is, say you have this kind of arrangement. So this is so, and at this surface, say you had at atmospheric pressure P0 at the top, because this is the surface. And now if you are trying to do what, you have added any pressure on this position. If I added, say here 2 Pascal pressure. So this 2 Pascal will be transmitted to every position in this liquid, to every particle. So this is what your Pascal law says. The Pascal law says is the pressure is same at all the point inside the liquids. Okay. And if you're trying to give any kind of external force, it will be transmitted in the same value to all the particles. Now, for example, if I have I have a region, I have here A point, B point, C point. So pressure at A will be equal to pressure at B is equal to C. So why? Because pressure is always dependent on what? Rho H G. So rho is constant, G is constant for particular liquid. So we say what? Height is the only variation where it depends on. So if you're taking different shape of utensils, but if the height of the thing is same, for example, if I'm talking, this is what is the shape 1, and the liquid is present here at this height, and then you have a shape in this fashion, and the liquid is filled here. If this H and this H are same, so pressure for this particular thing at this point will be same, because the pressure inside a liquid is directly proportional to the height of it. Sometimes it depends on the nature of liquid, that is what is density. When I'm trying to compare two different densities that time, but I'm trying to compare the same kind of liquid, so densities will stay same. So only variation will be there in the case of height. If height is same, then what we say that the pressure at all different point will be same. What is Pascal law? That at every point inside the liquid, pressure will stay same. And if you're trying to apply some pressure at any point of that liquid, that will be equally or the same value of the pressure will be transmitted at different points of the particles in particular liquid. That is your first law, which is what? It is Pascal's law. Now, based on this, again, we have one more law. We all have seen that. Example for this is Archimedes' law is what? Now, Archimedes' principle or Archimedes' law, before that, we are supposed to know and think what is that buoyant force. If you have seen, if you're trying to put, say, if you're taking a mug and you're trying to put that mug inside some water, so what will happen? This, if I have a liquid over here, so if you're trying to put it inside this way, so there will be a force applied by this particular liquid in opposite direction. That thing is what? That is known as force of buoyancy, or it is known as buoyant force. When something you're trying to insert or something you're trying to put inside the liquid, there will be an opposite force applied by the liquid to avoid that changes. This kind of force is known as what? Buoyant force or force of buoyancy. So this is now when I'm trying to define Archimedes' principle. What is Archimedes' principle is when a body is immersed fully or partly, and a body is immersed fully or partly in a liquid at rest, it loses its weight which is equal to the weight of the liquid displaced by that immersed part of the body. So this much story basically means what? That you have a thing, you did what is you took a liquid and you put a sphere inside this. Say sphere, this much part is inside this particular liquid. So this will do what? This will displace this much of liquid from here, because to make it space. So what will happen here is the amount of liquid which is being displaced from here will be equal to the weight of the body which is being immersed in this particular region. So that is what is known as your Archimedes principle. Okay, this is what is known as your Archimedes principle. So if there is a value for this, if I say this, I want to define something, so I have what? I have a thing known as apparent weight. And apparent weight is always calculated for those body which are fully immersed in. Apparent weight is only calculated for those body which are fully immersed. Okay, and it can be defined as, it can be given as mg in my 1 minus rho dash by rho, where rho is what? Rho is density of liquid, and rho dash is the density of the substance which is being immersed in that particular liquid. So apparent weight is only calculated for, this is only calculated for fully immersed body, for fully immersed body. For fully immersed body, we calculate apparent weight. Okay, this is what is fully immersed. So this is pressure, is basically the fluid is in dynamics. So Pascal law and Archimedes law, that's what you're supposed to read, and you're supposed to have idea of that. Okay. Now next one I'm talking about, the next thing which you're supposed to read in this is viscosity. Okay. So viscosity is what? Now, as we have in solids, what we say that we have something in motion. So if I'm trying to move, the motion is on this side, velocity or acceleration in this side. So what will happen? So there will be a force basically which is allowing me to move on this side. There will be an opposing force here, which is known as what? Friction. This is in the terms of solid. Same way there will be in the liquid, so that I have layers of liquids here. So I have basically again another layer of liquid over here. So this liquid will try to move on this side. So this liquid will try, this layer of the liquid will try to move on this side. This liquid of move on this side. So this is what, when you're going to this side, so this particular layer will go on this side and this particular layer will go on this side. So what will happen is there will be a opposing force, the relative motion between the layer of the liquids. So this will lead to what? This will lead to the development of frictional force, and that thing is known as viscosity here, which we denote by eta. The unit of eta, the viscous force, is defined as minus na dv by dr. This is potential gradient, this is area under this thing, this is what is unit, this is what coefficient of viscosity. This is coefficient of viscosity. The unit for coefficient of viscosity is, if I'm trying to write the coefficient viscosity unit, it is written as Newton second meter minus 2, or this is known as what? Poiseuille. Okay, this is known as Poiseuille. Okay. And if I'm trying to write out dimension for this, how much will be the dimension for this? ml minus 1 t minus 1. Okay, so this is how we try to find out dimension for, and it's better, it's actually best to find out what you, in your way, you should know how to find out dimension of any physical quantity or anything which you're studying in your any subject like physics and chemistry, whatever you are reading, all those physical quantities dimension, if you're able to find, it will be very good for you itself. Okay. Now next is what is, when I'm trying to discuss about the next thing here is Stokes law. Now what is Stokes law? We have to define about Stokes law. Stokes law is nothing but the whatever the viscous force will be there, like, so the viscous force which is FB, that will be given as the value for that viscous force which is arising because of the viscosity. The value for that is given by 6 pi eta RV. Okay, where what? V is the velocity of something inside the liquid. Say there is a situation where I have what? We have a liquid, and that inside that liquid you have a sphere of density rho. Okay, and so if some liquid is there, say I have a liquid over here, anything can be the liquid. So I know terminal velocity. I'll come to terminal velocity. Okay, so if I have FV is equal to 6 pi eta RV, so this particular V is what? Velocity of the sphere inside that particular liquid. This is what? This is radius of the sphere. Eta is coefficient of viscosity, and pi is constant, 6 is constant. Okay, now say if I am saying about this condition, so what will happen here is, what will happen in this condition, say if so this body, if it's trying to move it in this way, so the velocity will be in this direction. So with the velocity in this direction, the motion will be opposed by the viscous force. So viscous force will go into this direction, 6 pi eta RV. Now further, when I'm trying to say the body, because it's moving down, it will put a weight, that is mg. This weight will of this liquid will be given by mg. So that is what? 4 by 3 mass. If I'm trying to convert in terms of, if I'm trying to find out mass, it will be 4 by 3 pi r cube times rho into g, because weight is normally what? Mg. And Mass density is what? Density is equal to mass upon volume. Volume of sphere will be what? Mass volume of sphere will be 4 by 3 pi r cube. So if I'm trying to find out mass from here, I'll write m is equal to 4 by 3 pi r cube into rho, and g will stay here. So this weight will be acting downwards, and the buoyant force, because the liquid will try to oppose this, so the buoyant force will be acting on upward direction, and that buoyant force is given by again 4 by 3 pi r cube, but rho into g. Now, what is this rho? And there's a small difference between the because the density of liquid will be opposing, that will be buoyant force. And when I'm talking about the other thing, that is your sigma and rho. Two densities why I'm taking. So if I'm trying to define this, what will be their two density here? Sigma will be what? It will be density of sphere, right? It will be density of sphere. And if I'm trying to define what will be rho, it will be what? Density uh, of the liquid, whichever liquid I'm taking. Now, what is thing I'm trying to explain here is, so what will be there? This body will keep on moving inside the liquid. So there will be a point where what will happen here is total upward force will become equal to the total downward force. Total upward force will become equal to total downward force. That is what will happen here is 4 by 3 pi r cube sigma g plus 6 pi eta r v is equal to 4 by 3 pi r cube rho g. So this will be which condition now? Now what happens? Total upward force will be equal to total downward force. So in this condition, what will happen? That particular sphere or whatever particular thing is going inside the liquid, it will start moving with a constant velocity. It will start moving with a constant velocity. This constant velocity is known as terminal velocity. When what happens, when total upward force is becomes equal to the total downward force, what happens that particular material or the particular substance which you have dropped in that particular liquid will start moving with a constant velocity, and this constant velocity is known as terminal velocity. And if you solve this equation, the velocity, the v terminal, that is terminal velocity, you will get it as 2r square rho minus sigma into g upon 9 times eta. This will be what? Will be the value for terminal velocity. Now, if you see here, if I'm talking about terminal velocity, most all the terms are constant. This is constant, 2 will not change, eta will not change, 9 will not change, density of this will not change, density of sphere will not change, g is not changing. So basically I can write that terminal velocity is directly proportional to r square. And if I'm trying to draw the graph between this, it will come, if I'm trying to try the graph, it will come something like this. So this is what will be rectangular for parabola, you say, but this is what the terminal velocity is basically directly proportional to the square of the radius of the sphere which we have taken. Okay, so this is basically what we have to know. They see there is endless things when we talk about the theories in fluid mechanics, fluid dynamics. A lot of questions will be there, but whatever is required, try to read that much, whatever is important for your exam. In knowledge wise, very good. If people have studied throughout the year, very good. If you have read properly in 11th and you're just revising it, very good. If you feel like just I want to do how much ever result I can in this limited amount of time, you can go for this. There's no problem with this. Okay. Now next, when I'm trying to say next thing, we'll go for SHM, simple harmonic motion. Obviously, it's a very important topic and it is very much required as well. But what you can do is, instead of getting into lot in depth of SHM at present, what you can do, you can just read the formulas which is related to SHM. Okay, so time period in SHM is given by 2 pi root over m upon k, where k is your spring constant, or you can say the string constant. Okay, b is what? if I'm trying to find out displacement, so displacement is given as x is equal to a sine omega t. X is equal to a sine omega t. This will be where this will be at mean position. At mean position, and condition for this at mean position t equal to 0. Now it can be x is equal to a cos omega t as well, and cos omega t as well. This will be where at extreme position. It will be equal to what? It will be, this will be observed at extreme position where t will be equal to 0. Now in general, if I want to write, in general I write x is equal to a sine omega t plus phi, sine omega t plus phi, where when I'm trying to, for phi is what? Phi is basically initial. Phi is basically what? It is initial phase. Phi is initial phase, or this is also said as epoch. Epoch is also the same thing. You can say that initial phase. What is A here? A is basically, A is what? A is amplitude. What is omega here? Omega is equal to your what? Angular. We have read all this, so please try to revise this. Omega is basically your angular frequency. Omega formula is given as 2 pi upon t. That is 2 pi upon time period, and time period also can be written as frequency. So I can write the formula for this as 2 pi f. Okay, fine. Okay, the next thing here will be C. If I differentiate, this is what? X is what? This is displacement. If I differentiate displacement, I'll get what? If I differentiate displacement, I'll get it as the velocity. Velocity is given as omega amplitude square minus displacement square. Okay, you can find out V max again and V minimum here. V max will be when x is equal to 0. Now when I'm talking about mean position, basically what this is what is mean position, and this 2 is what? Extreme position. So if I'm trying to find out x is 0, it comes to mean position, this is 0. So that time obviously it can also, that time I can get the value. If a becomes 0, it will become negative, so that is not possible. So there will be some amplitude for particular wave. If I'm trying to find out acceleration, I'll differentiate velocity, I'll get acceleration. So it will be what? Minus omega square x. Again, in this also, I can find the value for what? Maximum acceleration and minimum acceleration. What is very important for you is finding out the energy of a body which is there in, which is having SHM, which is having simple harmonic motion. So for that, you should know what potential energy is. How much potential energy is equal to half m omega square x square. Kinetic energy is how much? Kinetic energy is equal to half m omega square a square minus x square. And if I'm trying to find out total energy will be equal to what? Half m omega square a square. If you add total energy, basically total energy is what? It is nothing but ke plus pe. If you add both of them, you get it as half m omega square a square, and it will be almost always a constant value. Why it will be? Because omega will be constant, a will be constant, and m will not change for our body. So it's almost every time it's a value which is constant value for this particular thing. Okay, so see, this is basically your small theory, concentrated theory for whatever is required in this. Okay, so now if what we can do is, see, this is mechanics section where you have questions, and obviously the questions are important. I'll not say the questions are not important. So if you have practiced previously also, very good. Now what we can do is we'll solve few questions. So we'll get ready for this one. Okay, so let's try. We'll try for the questions. Okay, we'll try doing questions now so that it can help everyone to learn mechanics more. So we'll start off with our dimension part only so that everyone can solve it. So the first question we'll start doing is, you need to find out Okay, the first question you have to find out here is what will be the dimensional formula of gravitational constant? The first question is that what will be the for dimensional formula for gravitational constant? Okay. So we have to find out say dimensional quantities dimension this G. So I know that what force is the gravitational force is given by G m1 m2 upon r square. I need to find out dimension for gravitational constant. It will be what fr square upon m1 times m2. Now force is how much? Force is Newton, that is mlt minus 2 into L square. Mass is how much? M, because I have two masses, so M square. This will do what is M minus 1, L minus 1, T minus 2. I have some answer. Solve it, check. Any of I think one of us are wrong. And Soviet is right. Correct? Soviet is right, correct? Everyone is getting answer what Soviet is getting. Soviet is right. Good. So next question, this is very basic question. We'll increase the label now. Now what is the question is which among this option, which pair does not have similar dimension? Which pair don't have similar dimension? I have word as tension. And next one, the first pair is surface tension and tension. Which pair does not have the similar dimension? Next pair is stress and pressure. Next one is stress and pressure. Third one is Planck's constant. Third one is Planck's constant and angular momentum. Angular momentum. Angular momentum is L. Angular momentum. The number D is angle and strain. Which pair don't have the similar dimension? That is what is the question. We have answer option A. Okay, so our first option only is coming around because tension will be what? It is a force, so it will have Newton. Surface tension, it was 4 per unit length, so it will be Newton per meter. So dimension is different here, ml squared T minus 2, and this is how much? Mt minus 2. So they were asking in the question that which have the different dimension. Stress and pressure, just now you saw angle and strain, both are dimensionless. Okay, these both are dimensionless. Okay, good. Next question is find the dimension of torque. Next question is find the dimension of torque. What is the dimension of torque? Dimension of torque. So torque is basically force into distance, perpendicular distance, whatever distance, it's distance, right? So mlt minus 2 times L. So it is ml square t minus 2. Komal, right? Dimension of viscosity we just now found out, ml minus 1 t minus 1. Okay. If yeah, got the right. If you all have read about Coulomb's law, we are going to discuss that when we are talking about electricity chapter. But at present, they're asking you to find out the dimension for epsilon naught. The epsilon naught. The formula for Coulomb's law is force is equal to 1 by 4 pi epsilon naught q1 upon q1 q2 upon r square. You need to find out dimension of this. This is epsilon naught. Can anyone can you try? Epsilon naught. Komal says dimensionless. No, Komal, it's not dimensionless. Try. So which says m minus 1, l minus 3, t4, a2. So which is right. So which is right. Why Soviet is right? Because see, if I'm trying to find out epsilon naught, because this is constant, I don't have to care about the 1/4 pi. The formula for this will become Q1, Q2 upon FR square, right? Now Q1 and Q2 is basically charge. Charge will be written in what? AT. Because I have two charges, so it will be written as AT square upon Coulomb square is Coulomb is not the dimension Koval. When I'm writing dimensional formula, we should change it to. That's why we are trying to write this. I is equal to Q upon 2 time. So whenever getting charge dimension I don't have. So what I do is I can write charge in the form of IT. For current I have ampere, for time I have T. So I can write it in this form. So AT square, FR square is MLT minus 2. Okay, MLT minus 2 into L square. So if you solve this, it will become what? A square T square upon ML cube T minus 2, which gives you final answer as M minus 1, L minus 3, A square and T raised to 4. Okay, yeah, got them correct. Yeah, okay, let's go to the next question. I will try to go into the next formation of the questions. Okay, the question says is what is a particle is thrown vertically upward. We are throwing some particle vertically upward. Okay, That's the first line. Its velocity at half of the height, whatever total height is there, so total height is h. So its velocity at half of the height, so h2. So velocity at h2 is given to 10 meter per second. I'm not dictating full question. Then the maximum height attained by it will be how much? The question, I'll repeat it. A particle is thrown vertically upwards. Its velocity at half of the height is 10 meter per second. You have to find out the maximum height. G is supposed to be taken as 10 meter per second square. Options are 10 meter, 20 meter, 15 meter, 25 meter. I can repeat the question if someone have not heard. It is basically what a particle is thrown vertically upward at half of the height. The velocity is 10 meter per second. You have to find out the maximum height. Dipesh have an answer 20. Dipesh have an answer 20. Anyone else? Good that all are trying. Whoever is not trying, I'll assume that they don't want to try, or maybe they'll be knowing that. It's good if you're knowing it, no problem. If you're not knowing, I'll request that you should try. These are basic questions to just clear your concepts. Higher level questions, how much ever you want, you can solve, no problem. Few here and there questions I am giving you, which are previous year questions. These all are previous year questions from some or other reputed exams. Okay, let's try saying Dipesh will see the answer. Though you have attempted it, it's very good. We'll try to see what it says. Now, what it is saying basically is the particle have been thrown up. Okay, so if I'm trying to use formula for the first cases, say I have v square is equal to u square, and because it's being thrown up, I'm throwing to its upward direction, so it will become 2gs because it's against the gravity, so I'll write it as minus 2gs. First thing. Now, because it is starting from initial thing, so I'll see what is, because it's starting from initial thing. So if for the first situation, when it reached to h by 2 position at h by 2, when this is reaching at h by 2. So what I'll write here is, at this time, the velocity was how much? 10 meter per second square. So 10 square is equal to u square minus 2g h upon 2. This is what I am getting here in this position. This is what is my value. Correct. This is what I'm getting. I'm getting u square, and that is 2gh by 2. Okay. Now, if I'm trying to leave this equation in this format, okay, or if I'm trying to take LCM, I'll write as about 2u square. Avinash, I have got the answer as 10. Avinash, you're right. 2gh upon 2. Gotham 10, right? So this will give you answer as u square gh. So I'll take this as equation 1. Now next thing, for the final velocity, v will be 0. So I'll write it out. 0 square is equal to u square minus 2gh. Is h is the maximum height. So u square will be equal to 2gh. Now what I'll do is, this is equation 2. I can use u square as 2gh in this. So what I'll get from here, so this equation, this is my first equation. I'm using the first equation. First equation, I'll use value from the second equation. I'll get it as what? 100 is equal to 2gh minus gh, which gives me answer as what? Gh is equal to 100. Now they have said me what? To use g as 10. So 100 upon 10 is nothing but 10 meter. So whoever have got 10 meter, answer is right. Okay, yeah, Govind, the other was right. Okay, very good. Everyone who is trying, I appreciate their work. So you don't think that getting wrong and right, first just try to attempt the question. Okay, that will give you a lot of confidence. Okay, I have another good question. So the question says is what? A body starts from rest with an acceleration a1. There is a body which starts with rest. So see, if I'm saying a rest, then it will be obviously at 0 and acceleration a1. Okay. After 2 seconds, another body B starts from rest with an acceleration a2. So this is body 1. And another, the next body 2 is there. The body 2 again, it starts after what? It starts after 2 seconds. After 2 seconds, another body B starts from the rest with an acceleration a2. So for this, acceleration is a2. Okay. If they travel equal distances in 5th second, if they travel equal distance in 5th second. The question is this: if they travel equal distances in 5th second after start of A, you're supposed to find out ratio of A1 to A2. Ratio of A1 to A2. Question is, you have two bodies. So a body starts from rest with an acceleration a1. After 2 seconds, another body B starts from rest. This B also starts from rest only. After, okay, another body B starts from rest with an acceleration a2. If they travel equal distances in 5th second after the start of A, you need to find out the ratio of a1 to a2. This line, the last line I've written because that have an importance. If they travel equal distance in 5th second after start of A, then you have to find out ratio of A is to 2. Gautam have an answer 5:9. Gautam is getting 5:9 and Avinash is getting 9 upon 5. 5:9. A1 is to A2 I have to find. Govind also is saying 9 upon 5. I have two kind of answer with the same question. Let's see, still I am saying A1 is to A2. A1 is to A2. A1 is to A2. Govind and Avinash, and all three ways try to check your answer. See, the only thing what is important here is if you see properly what they have said is at fifth it is same. So what you have to basically what A's will be there in the fifth will be equal to the B's in 3 seconds. This is what is the first, that's the only concept there in this. Because I have mentioned what they have equal distances in fifth second after start of A. So because B is starting after 2 seconds of this, the S5 of A will be equal to S3. Now because both of them have started at rest, so I can write that here what is there is, this will become 0 plus 9 by 2 upon A1 using which formula? Using U plus 2n minus 1 A upon 2. Nth formula. Nth formula is what? Sn formula is U plus 2n minus 1 A upon 2. This is what is the formula for nth second. We have written the formula. Formulas, if you know, it's enough to solve all these questions. There is nothing more difficulty in this. 2n minus 1, so 6 minus 1, and then here 2 into 5, 10 minus 1, 9 by 2. So 9 by 2 upon A, 9 by 2 into A1 is equal to 5 by 2 into A2. If I'm writing A1, so this and this gets cancelled. A1 upon A2 is, I'm getting it as 5:9. 5:9 is what? Avinash and Govind, check your, I think you would have done A2 to A1. Only that one will be your mistake. Maybe, please check. If I'm also checking if I have done any mistake. Okay, fine. Okay, the next question is, okay, so next question is the two spheres. The next question is basically two spheres of same size. We have two spheres, say I have A and B, two spheres. They have same size. The first point given is they have same size. Second one, they say that one of mass 2 kg and another of mass 4 kg. This both are there. They are dropped from the height of Qutub Minar. So the height from dropped from height height of 72 meters. Let's assume that to be 72 meters. When they are 1 meter above the ground, okay, the question is they are dropped from height of 72 meter when they are 1 meter above the ground, 1 meter above the ground. Okay, what will be same for this two sphere? What will be same for this two spheres? Okay, the question is this. It is they are the same size. The mass is 2 kg, 4 kg. They are dropped from the height of 72 meter. When they are 1 meter above the ground, what will be same? Options are momentum, kinetic energy. The first one is momentum P, potential energy, acceleration. This is what? This is momentum. Momentum. What will be same? Momentum. Then you have acceleration. Okay. Same size. Mass is 2 kg, 4 kg. They are dropped from the height of 72 meter when they are 1 meter above the ground. Which among the following will be same for them? Samir says PE. Komal says acceleration D. Gautam says acceleration. Dipesh says PE. Govind says D. Okay, fine. Now see, it's falling. Yes, Samir, it's falling. It's being obvious. It is being dropped. They are being dropped from 72-meter height. Samir says KE. Now see, if we are justifying everything. See, here mass is different. Ritik says D. So D is correct answer. Reason why is because they are falling, the acceleration due to gravity will be only acting on both of them. Momentum, K, P, formula for momentum is mv. Formula for kinetic energy is half mv square. Formula for Pe is mgh. All this depends on the mass. Mass is not same. Size is same. So what will be same for both of them when they are being dropped at 1 meter above the ground throughout the 72 kilometer? What will be same? 72 meter when they are being dropped. G will be same. So whoever have given the answer as D, it's correct. Whoever have not guessed it correct, I have just given you the logic. You can use it for the further questions. Okay. Next question is, a particle is thrown vertically upward. A particle is thrown vertically upward with an velocity of 4 meter per second. Okay, 4 meter per second. The ratio of acceleration, the ratio of acceleration after 1 second, the ratio of acceleration after 1 second and 2 second will be what? For the same motion, a particle is being thrown up. They are asking you what, and the velocity is 4 meters per second. They are thrown with a velocity of 4 meters per second, that particular particle. What will be the ratio of acceleration after 1 second and 2 second of the same motion? Same. Gautam says same. Gautam answer is right. Why it will be same? Because both will be only, I am asking ratio of acceleration. I'm not asking ratio. So ratio of acceleration will be what? Minus G minus. Very good. Gautam, correct. Acceleration due to gravity. Reason also Gautam have given. Okay, fine. Let's go to the next question. A body is thrown vertically upward. A body is thrown vertically upward. Okay, and this is being thrown vertically upward with a velocity of 19.6 meter per second. Okay, the question is the position of body, the position of body after 4 seconds. They're asking you the position of body after 4 seconds. The point 1 will be highest position. Point B is at the midpoint of the line joining the starting point and the highest point. Midpoint of highest and starting point. Highest and starting point. Number C will be what? At starting point. So at starting point, after 4 seconds, what will be the position of the object which is thrown? And none of these. This is the next question. Gautam says highest. Let's see, Gautam, few more 1-2 answers. Samir says at starting. Gautam says again starting. Komal says none of these. So we have answer of all the options. Avinash says none of these. Okay. Now see, when I'm saying, so let's say if I'm just substituting it that V is equal to U minus GT because it's an upward motion. Govind, the other says midpoint. Avinash also says midpoint. A lot of answers from midpoint. Let's see. So U is equal to minus GT. So what I can do is, I'll just, so U will be 0. So it will be what? Minus, U will become 0 minus U. So I'll do what is, I'll write it as in this form. GT is equal to how much? V minus U. So time will be how much? V minus U. V is how much? 19.6 minus 0 upon return back to starting point. Gautam, correct? See, so this is 19.6 upon 9.8. This will give me answer as 2 seconds. So what is there is at upward at 19.6 is went to 19.6. That time the time was 2 seconds. Okay. The question data they have given you this only: a body is thrown vertically upward with a velocity of 19.6 meter per second. The position of body after 4 seconds will be how much? So when I'm trying to find out T for this thing, it is 19.6. For 19.6 velocity, the time will be what? 2 seconds it will take. But the time given here is how much? 4 seconds. So 2 seconds for going up, 2 seconds for coming down. So answer 4 seconds, it's at starting point. Okay. So yeah, Vinas, correct. Okay. We'll do one more last question in kinematics, another type. The coordinates for X is 80 square and Y is BT square. This is what? This is coordinates of a particle moving at any time t are given by this. Okay. This is basically, you say coordinates if a body is moving in somewhere here. So at this position, X and Y value they have given. And you have to find out speed. Basically, you have here that this is distance and this is time. The question is given. This data is not given in this. I'm just to explain you. I'm not dictating you full this thing. I'm not writing. The coordinates of X and Y is given in this fashion. That means basically a distance is given. You need to find out magnitude of a speed. Options I'll give you here. I have options. This is an objective question. So 2t a plus b. Option B is 2t root and over a square plus b square. Number C is 2t root over a square minus b square. I already have answer. B with Avinash, I have the answer. Root a plus b square. These are the options. Two t a plus b square. Yeah, Avinash is right. Gautam right. Komal right, Govind, Yadav right. Everyone is getting answer as B. Samir also got B. I think everyone is getting the same answer. No need to solve this. Good. Okay. One. Take one. Okay, last question. A ball is what? It's a tower here. A ball is being released from a tower. There's a ball which is released. This is a tower. From the top of the tower, a ball is being released. Okay. The height of the tower is h. Okay. At to okay, I'll write it as to reach ground, or to come from the top to reach ground, it takes t seconds. Okay, it takes t seconds. So what will be its position? So find position of ball at t by 3 seconds. That's what is the question. Okay, options are 8h upon 9, 8 upon 9 meters from ground. Number B is 7h upon 9 meters from ground. C, h by 9 meter from ground. This is also in meter. Option D is 17h upon 18 meters from ground. These are the 4 options. A body is thrown from the top of the tower of height h. To reach the ground, it took t seconds. Find the position of the ball at t by 3 seconds. These are the options. Okay. Gotter says answer as A. Avinash have answered as C. So here we have contradiction, 2 answers. Let's wait for another. Ritik says A. So we have 2 answers as A. Because it's being thrown from the top of the tower, height will be equal to half GT square. Now half GT, Samir also says 1, so half GT square. So now when I have to find out it for t by 3, how I'll write? H is equal to, say I'll write it as h dash. So h dash is equal to half g t by 3 square. Okay, if I'm trying to write this, it will be what? Half. It will become gt square upon 9. If I see from here, half gt square is equal to half gt square is equal to half gt square will be equal to h. So I got it as h upon 9. Now because they are asking everything from the ground, so this is h by 9 from ground. No, this is h by 9 at 3 seconds. So from ground, if I'm trying to find, it will be written as what? H minus h upon 9, which will give you answer as 8h upon 9. So option A. I hope things are getting clear. I will get it to projectile motion. Next thing. Okay, yeah. Good. We'll do a few questions. Let's not have your this thing down. Okay, we have a question related to vector now. We have question as 2 equal vector. We have 2 equal vectors. 2 equal vectors. 2 equal vectors have a resultant. 2 equal vector have a resultant have a resultant equal to either of them. It has to be equal to either of any of them, either of them. Okay, so in that condition you have to find out angle between them. Angle between them is equal to how much? Option A 110, option B 120, option C 60, option D 150. Two vectors, they are equal and have resultant equal to either of them. You can choose any of them, and this is what is the first question. Samir have an answer 120. If anyone who, I think if it's just direct formula type question, okay. If you apply it from the equation also you'll get, but answer of Samir Govind is correct. It's 120 degree. We have to use which formula? Formula used will be equal to R square A square plus B square plus 2 times AB cos theta. As everything is same over here, with this all is been going to be same, right? Two are same. So one can be cancelled by one another. Right? We can solve it. No problem in solving this. This, if I am assuming everything to be R, it will be what? R square. It will become what? 2A square plus 2R square. Then it will become 2R square cos theta. So this will basically become what? R square is there, then you take 2R square common, it will become 1 plus cos theta. Rn square gets cancelled. 1 plus cos theta is equal to how much it is coming? 1 plus cos theta is equal to 1 upon 2. So cos theta is equal to 1 upon 2 minus 1, which is equal to minus half. Whatever answer you get after that. You can do it in multiple methods. So answer is 120 anyway. You can use other trigonometry ratios also if you know the formulas. Answer is 120. Answer, whoever got 120 is right. So good. Next question, we'll take next question as two projectiles are projected with same velocity. We have two projectiles. Two projectiles are there with, they have same velocity. Two projectiles with same velocity. If one is projected at angle of 30 degree, one is projected at an angle of 30 degree, another is being projected at an angle of 60 degree with horizontal. This both is with horizontal. 30 degree and 60 degree with horizontal. Okay. Find the ratio of maximum height reached. You need to find a ratio of maximum height. Ratio of maximum height. Options are 1:3, B is 2:1, C is 3:1, fourth one is 1:4. Two projectiles projected with the same velocity. Angle of projection for one is 30 degree, for other it is 60 degree with horizontal. The ratio of maximum height will be A 1:3, 2:1, 3:1, 1:4. Gautam and Avinash have answer as 1. That is 1:3. One is to 3. Samir also have options. All are getting answer same. So no changes in answer. Everyone is getting A. You have to use directly that formula, which is the formula for horizontal height is what? H is equal to U square. H is equal to U square sine square theta by 2G. We can use it for both of them. You'll get the ratio. Because U is same, U is getting cancelled. So whatever is left is only the angles. 2G gets cancelled, U square is square. So basically it's only theta. So one place I get sine square 30 degree. Other I'm getting it as divided by sine square 60 degrees. So this is what will be the answer. Everyone is getting A. Komal also got A. Answer is correct. No confusion. Next, move to the next question. Good. Everyone is trying. I'm getting support. So speed. Okay. Okay. A projectile can have the same range R for two angles of projection. Okay. The question is this. Please listen to the questions. A projectile. Okay, I'll write it down. A projectile can have same range R for two angles of projection. Two angles of projection if T1 and T2 is the time of flight. T1 and T2 are what? Time of flight for two cases. Time of flight in two cases. Okay. Then product of two time of flight is proportional to. Then product of two time of flight are proportional to. Options are A 1 by R square, B R square, C R, D 1 by R. This is the full question I've written. Good question. Komal, Govind, answer they're giving it C. Samir got the answer as B. See, answer will be C only. This is actually a formula. which it's better you remember it also. See, when I'm writing it as projectile can have same range for two angles of projection. Which are those angle of position? If one is theta, other one is 90 minus theta. For this two situation, range will be same. Okay, 90 minus theta and theta, this for this two projections, they will have the same range. So when you substitute, when you try to find product of this, you'll basically get it as T1 into T2 is equal to 2R upon G. Sorry. It's basically you'll get T1 into T2 is equal to 2R upon G. This is what you'll get when you multiply. So you can see that they're asking you proportionality. So 2 and G being constant, I can write the product of that is proportional to R. So going with that, option will be C. This you can write down for your remembrance. Two angles in which the range will be same. That will be theta and 90 minus theta. Product of T1 and T2 will be equal to 2R upon G. Good question. You can write down in the terms of question only. Okay. So next question is, if R and H represents the horizontal range and maximum height, R what it represents, H again same what it represents. R is your range and H represents maximum height in the terms of when I'm talking about a projectile. Okay. Then what is the relation which exists? H by R, this if you know, very good. If you don't know, I'll just tell you, you need to write it down. You need to remember this as well. Okay. 4 by R cot theta P. Okay, I'll just try if anyone knows. R by H is equal to 4 cot theta. Number C is equal to H by R equal to 4 tan theta. And number D is equal to R by H 4 tan theta. This is a formula how R and H will be related. Just giving you the important formulas which you can solve a lot of questions directly from projectile. Okay, Samir says Gautam got the answer. Samir both all they're saying B. Okay, so answer is B anyway. The formula, this you remember in the terms of formula also. You can do it also when you're trying to find out R. R will be basically what it is 2u square sine theta cos theta upon G, and H is basically how much? H is equal to u square sine square theta upon 2G. So if you, I can divide any to any. If you want to divide R by H, you divide, this gets cancelled, this gets cancelled, this gets cancelled, this gets cancelled. 1 square is got. Okay. So basically I'll get what? R by H, I'll get it as 4 cos theta, because 2 and 2 will get multiplied. So 4 cos theta upon sin theta, you'll get it as, so which will be equal to 4 cot theta. So good one, everyone. Just whoever have not written all this, just this all is projectile. You say, you can say it as short tricks also, you say, or you can say it as normal concept formula. Okay. One more I have. Let's take that. We have a projectile can have the same thing. A projectile can have same range for two angles of projection if h1 and h2 are the two maximum height for the two cases. Then whenever I'm trying to find out relation, so r will be equal to how much? This is option A. The question is what? The question is same. A projectile can have the same range for two angles of projection if h1 and h2 are maximum heights. When the range in the two cases are r, then the relation between r, h1 and h2 you have to say. The relation between h1 h2 is 4 h1 h2, number 1. Number 2 is r 2 root under h1 h2. Number 3 is r is equal to root under h1 h2. Number D is none of these. Okay, these are the options. Samir have answer as no. Answer for this will be A, Samir, because this is all formulas I suggest everyone to remember. Okay, the two conditions where the theta will be same, like r will be same for that theta. The theta will be theta and 90 minus theta. If you solve this fully, you'll get it as in the form, you'll get it in this form. R square will finally come it as 16 h1 h2. So R will come as 4 root under h1 and h2. Everyone, the last three things which you have done is all like it's basically formula which we are doing. So please don't try to skip it. Try to remember the formulas. It will be useful for you for your faster calculations. Okay. Okay, we'll go to the next questions. Okay, the next question is of a body of mass 5 kg, a body of mass 5 kg have a momentum of 10 kg meter per second. A body of 5 kg mass have a momentum of 10 kg meter per second. When a force of 0.2 Newton is applied on it, the force for 0.2 Newton is applied on it for 2 seconds. For 2 seconds. When I'm applying a body of mass 5 kg has a momentum of 10 kg meter per second. When a force of 0.2 Newton is applied on it for 10 seconds, the change you have to find out what? Delta Ke or change in kinetic energy. What will be the change in kinetic energy? You have to find out. Need to find out change in kinetic energy. Okay. See, now when I'm trying to find out for this question, you need to find out change of momentum first. First, you're supposed to find out change in momentum. The change in momentum you're supposed to find out by using what? Final and initial momentum question. Okay. In this options, I have now, this is a subjective question. The answer for this will come as 4.4 joule. Okay. What will be the initial momentum when you're trying to find out this? Okay, let's solve it. Change in momentum delta V will be given by force time T. Now force is equal to 0.2. Okay, and you're trying to find out the time for it. So 0.2, and then I'm trying to change it just for 2 seconds. Trying to find out delta P. So delta P will be force into time for 0.2. From this you'll get the momentum. Then you'll find out what? You'll find out initial velocity. Then for using this, you'll find out initial energy. When you got this true value, then again you'll find out what? Final velocity, and then you'll find out final energy. So this final energy minus initial energy will give you delta Ke. Okay, so this is how you'll solve the fine. This is basically is mechanics questions. Still more you can practice on your own. Okay. Your physics class is over for now. After a break for 15 minutes, again, your math classes will be resumed. Okay, fine. So thank you.
Good evening, everyone. We'll have maths class in another 15 minutes. Please be back by 6:45 Indian Standard Time. Okay.
Hello, sir.
Yes. Hello. Hello. Good evening, everyone. Good evening, guys.
Good evening, sir.
Good evening. Please try to respond in the chat box, guys. Good evening, Govind, Dipesh. How many more are actively participating here? Good evening, Komal. Good evening, Samir. Sujan, good evening. Good evening, Ritik. Gautam, Avinash, are you there? Okay, so we'll start with the class. As you see, the topic is sets, relation, and function. So what is a relation? A relation in R is a set. A is a subset of A cross A. What is the meaning of A cross A, guys? What is the meaning of A cross A? There are two sets, set A and set A. So now let's suppose set A is A, B, C. Set another A is obviously again the set A, B, C. Okay. So what is A cross A? What is set A cross A? Elements will be A, B. The elements of set A cross A will be A, B, then AC, BA, BB, BC, CA, CB, CC, correct? So these are the elements of set A cross A. Okay. So thus relation R is a relation in set A belongs to R. What is the meaning of R? What does R represents? What is R, guys? R stands for? So in this case, R belongs to relation is subset of, this is subset A cross A, okay? So we'll try to understand it better with the example. Let A be as 1, 2, 3, 4, 5, 6, and let R be a relation in A given by A minus B equal to 2. So what is the relation given here? What is the relation given here? A minus B equal to 2. Now, what we have to find? Is it a relation or not? It is a problem of relation or not? Okay. So what are the numbers? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Now in this, which are the numbers? In this, which are the groups? Like A, and let's suppose if I take it as B. So in A and B, which are those numbers which satisfy this relation? Which are those numbers which satisfy this relation? That is A minus B gives me 2. So first one is 3, 1, 4, 2, 5, 3, 6, 4, correct? So these are the numbers which is having a relation in A and B. This is the definition of relation. The first set is related to B with this definition, correct? I hope you're getting it, guys. Set A and set B are having a relation that is 3 minus 1 gives me 2. 4 minus 2 gives me 2. So this is the rule. This is the set of rule which defines this relation, correct? Now 3, 1 is defining this relation, but 1, 3 is not defining this relation, correct? So no, that's what is given here. 1, 3 is not a relation. 2, 4 is not a relation. 5, 6 is not a relation. I hope you're getting it, guys. So what we have studied till now, the product of A cross A, set A into set A, how it is ordered pair. Then what is the relation? Relation is a set of rules. You can understand like this. Relation is a set of rules which defines the relation between the two sets. Set of rules which defines the relation between two sets. Like this is the relation, correct? What is the relation here? A minus B equal to 2. Now the values which satisfy this relation, we say those values are in the relation. Otherwise, those values are not a relation, correct? What is the meaning of R cut, R strike? If you strike R, what is the meaning of that? It is not a relation, correct? I hope you're getting it, guys. So we are going with the very basic of relations. Now coming to the next one, that is domain and range of a relation. So in the previous problem, in this problem, can you tell me what is domain and what is the range for this problem? Anyone? What is domain and what is range for this problem?
Domain is 3, 4, 5, 6, and range is 1, 2, 3, 4.
Very good. So what is the domain?
3, 4, 5, 6.
So domain is all the values which are used here, correct? So it is 3, 4, 5, 6. And what is the range? All the values which we have used in B, set to B. So it is 1, 2, 3, 4. Okay. What is codomain? Anyone? What is codomain?
1, 2, 3, 4, 5, 6.
So all the values of set A is considered to be codomain, correct?
Codomain.
All the values of set A is considered to be codomain. Anyone has got any doubt till here? Tell me, guys. I expect more number of people to respond in the chat. If you have any doubt, please ask the doubt. If you don't have
Everything
doubt,
is
at least
clear.
say no. Yeah, tell me.
Everything is clear, sir.
Okay, fine. So we go to the next one. Yes, now math session has started. Okay, sorry. I was looking to the wrong. So again, this is domain and this is range. Okay, for this example, again, we'll try to find out. We'll try to check. So A is from 1 to 16. B equal to A square. So what is the square of A? What is square of 1?
1,
Square of 1 is 1. What is square of 2?
4,
Square of 3?
9,
Square of 4?
16,
Square of 5?
25. But then,
But can we take 25?
no, because there is no 25.
Because the limit is only from set A is only from 1 to 16, correct?
Yes.
So since set A is only from 1 to 16, so we don't have more than this. So what is the range? 1, 4, 9, 16. What is the domain? 2, 1, 2, 3, 4. Okay, guys. In other words, it is like if we go into the functions, it will be a totally different thing. So there are few different type of sets. Sorry, different type of relations. Now in this relation itself, if in this problem itself, if I write B, the relation is defined as
B equals to A square.
B minus, sorry, B equal to A minus 17. What is the domain? What is the range? In this one only, if we have B equal to A minus 17, then what is the domain and what is the range?
No domain and range.
No domain, no range, correct? We don't have any domain, we don't have any range, correct? So this is called as what? Empty relation or empty set, correct?
Or null set.
What are you saying? What are you saying?
Null set.
Null set, yes.
Yeah, null set or empty set or phi, correct? So this is the example, that was the example of this. Like A minus B equal to 6. Now A minus B equal to 6 will never get, correct? In this set, if the value of A is 1, 2, 3, 4, 5, then A minus B equal to 6 will never get. So it is called as what? Void relation or empty relation. Okay. Now you have universal relation. If the relation is A cross R, A cross A, that will take all the elements of A, correct? All the elements of A is used in this. So if all the elements of A is like domain is also all the elements of A, and range is also all the elements of A. So that is called as what? Universal set. If each element of A is related to every element of A, this is of A, this is A. Each element of A is related to every other element of A. So that is called as what? Universal set. Next one, we have identity relation. The relation, identity relation, identity A is equal to A comma A belongs to A is called as identity relation on A. Like 1 is connected to 1, 2 is connected to 2, 3 is connected to 3. So if I just take this one out, it will be called as identity relation, correct?
Yes.
So that is a few type of sets. The more important one is reflexive, symmetric, and transitive. Many a times they have asked questions from here. Reflexive, symmetric, and transitive, correct? What is reflexive? If A comma A belongs to R, for each A belongs to A is a relation to A for each A of A. A is subset of A. Okay. So that is called as reflexive. Are you able to get it, guys? What is reflexive?
Can you illustrate it with the diagram?
Yes. Say, for example, if we take it as congruent triangle, okay? So this is like ABC. This is PQR. This is side A, side. So obviously this is like ABC, okay? So this triangle is reflexive because this side, if these two are congruent, what will happen? AB equal to PQ, correct? You know, guys,
Equal to Q, yeah.
congruency. AB equal
Yes,
to
sir.
PQ. If AB equal to PQ, if this is A, so this is also A. Now, if
Yes.
I change their values, if I change their place, A, comma A, or if I write again A, comma A, it both are the same thing, correct?
Yes.
What I'm trying to say, 1, comma 2, 2, comma 1. Now, 1, comma 2 and 2, comma 1 is not same thing. But if I write only 1, 1, 1, 1. Now, if I change their places also, it is still the same thing, correct? Like in this case,
Yes, sir.
Okay.
both are A. So we write, let's suppose first triangle is written as A, second is also written as A. Now, instead of writing first triangle here, first triangle, second triangle. Now, if I change second triangle to first triangle, still it will be A, correct?
Yes, sir.
Are you getting the point? So that is called as reflexive. Means if you change its position, it doesn't affect the sets. Okay.
Okay.
Then what is reflexive?
If the position changes, then
What is symmetric? What is the meaning of symmetric, guys? Anyone?
means
You have studied this in your class
biology.
12th?
Symmetric means
You have studied
equal
or
in
not
both
studied?
sides.
What guys?
If we have a symmetric line, so there is equal part in both the side. That is symmetry.
But what about symmetric functions?
The symmetric function.
So this we haven't read until now, I think.
Yeah.
This type of function.
Reflexive symmetric, you have not done in your class?
Yes, sir. We haven't studied. I think it isn't in our syllabus also.
It may be, but or it may not be in our textbook book or syllabus. Yeah.
Okay. See, the thing which is written here is wrong. It is like if A, comma B belongs to R, relation of R A to B is equal to relation from R B to A. If this is true, then we say it is symmetric. Now again the same thing. Our congruent triangles are symmetric, correct? Yes or no?
Yes.
So
If this is the sides A, B, C, and here if this is the side P, Q, R, P, Q, R, okay? So we write, if let's suppose if I write A, comma, P. Instead of A, comma, P, if I write P, comma, A, both are the same thing, correct?
Yes.
Are you getting
Yes,
the
sir.
point? A, comma, P or P, comma, A, both are the same thing because the values are same, correct? Another example we can take. Let's suppose the relation is defined as A plus B. The relation is A plus B. 1, comma 2. Now, what is the value of 1, comma 2 here?
3,
3.
You will get how much?
3.
1 plus 2, that is 3. And what is 2, comma 1?
3.
It is again 3. So we say that relation A plus B is symmetric. Are you getting the point?
Yes.
Yes, sir.
Another example, can you tell me any other example of this one?
A minus B. No.
Okay, tell me A minus B.
And both are same.
A
One
minus
one.
B is symmetric, non-symmetric. If you take 1, 2, how much value will get?
It will be non-symmetric, sir.
It
Minus sign. Minus 2 is minus 1 and 2.
Minus, and what is 2, 1? 2 minus 1 is 1. Is this two values same?
No, sir.
No. So A minus B is not a symmetric relation. So A minus B is not a symmetric relation, right? It is non-symmetric.
Okay, sir.
Any other example can you give?
Of symmetric or non-symmetric?
Symmetric.
A into B,
Symmetric.
sir. A into B.
Yes.
Very good. A into B is symmetric, correct? Now someone has given very good example in the chat.
Yes.
Modulus.
Sujan has given the correct, very good example of symmetric. Now this equation only, if I put here mod, it will become symmetric, correct?
Yes, sir.
Mod of -1 is also 1 and mod of 1 is also 1. So in this equation only, if I put mod, it will become symmetric. I hope you're getting it, guys.
Yes.
Next one is which one? Transitive.
Well,
So transitive is like if A comma B is true, if A comma B and B comma C, if both of them are true, then A comma C is also true. If this is true, then this is also true. For example, again, our I take little bit different. So this is, let's suppose, triangle A, this is triangle B, this is triangle C. Okay. Now, if triangle A is similar to triangle B, and if triangle B is similar to triangle C, then triangle A is also similar to triangle C, correct?
Yes, sir.
Yes, sir.
Are you getting it? If
Yes,
A,
sir.
triangle A is similar to triangle B and triangle B is similar to triangle C, then triangle A is also similar to triangle C. So this is what? Transitive. Any doubt, anyone? Did you get it? What is reflexive, transitive,
Yes, sir.
and symmetric? Now, in this itself, if we have, let's suppose, any relation which is reflexive, symmetric, and transitive, that is called as equivalence relation. Any relation which is all the three are true in the relation, that relation is called as what? Equivalence relation. So our congruent triangles, 3 congruent triangle is the equivalence relation, correct? Yes or no? 3
Yes, sir.
congruent triangle is reflexive also, is symmetric also, as well as transitive also. If first triangle is congruent to second, and if second is congruent to third, then first is congruent to third, correct? So that is transitive. What about symmetric? the sides of each of these sides, that is, if I write A comma B, the first side is A, here it is B. So if I write A comma B, so A comma B, or if I write B comma A, both are true, correct? Are you getting it, guys?
Yes, sir.
Try to solve this problem, everyone. What is the answer? Select n with a set of all natural numbers and let R with the relation in n defined as this. A is a factor of B. A is a factor of B. Okay. So B by A should be true, correct? Then show that R is reflexive and transitive but not symmetric. Okay. So what do you mean by reflexive? How we can prove it reflexive? A comma I means 1 divided by 1 is 1, correct? It is possible. Next is 2 by 2 is also 1. So that is also possible. 3 by 3 is 1, correct? Are you getting the point? So each of this number can divide each of the same number and will get every time 1. So this is a relation which is called as reflexive. What about transitive? What about transitive? What was transitive? A, B, B, C, correct? So if B is divided by A is true, and if C is divided by B is true, then C should be divided by A, correct? Are you getting it, guys? If B by A is true, then C by B is true, then obviously C is a number which is also divisible by A, correct? For example, let's suppose if I take the number as 4 and A as 2, B as 4, A as 2, and C as 8. Okay. Let's suppose this is like 5, 6, 7, 8. Because this is dot dot dot. This is all the natural numbers. So if B is 4, A is 2, and C is 8. So it is like 4 divided by 2. This is true. Then obviously C, that is 8 divided by 4 is also true. Then 8 is also divisible by 2, correct? Are you getting the point? Guys?
Yes, sir. But we get 2 in 4 by 2 and 8 by 2, but there is 4 in 8 by 2.
Yeah, A, B, C is 3 different numbers. If P divided by A is true and C divided by B is true, then obviously C is divisible by A is also true. That's what we are proving. That's it.
Okay.
So 4 is divisible by 2, 8 is divisible by 4. So obviously 8 is divisible by 2 also, correct?
Yes, sir.
Are you getting it, guys? Komal, any doubt? Shalija, any doubt? Samir?
No doubt, sir.
Avinash, any doubt? No doubt, guys?
Everything is clear, sir.
Yes, Dipesh, it is clear. It is correct. See, if 2, 4 and 4, 8 is true, so 8, 2 is also true, correct? Like 2, 4, if it is true, that is A, B is true. 4, 8, that is B, C is true. Then 2, 8, that is 8, C is also true. and this is happening in this problem. So that is the reason it is symmetric. This is what do you call that? Transitive. What about symmetric? Why it is not symmetric is? See, this is not symmetric because 8 divided by 4 is not equal to 4 divided by 8, correct? 4 divided by 2 is not equal to 2 divided by 4, correct? Means A comma B is not equal to B comma A. That's the reason it is non-symmetric. You got it? Understood, everyone? We'll go to the next one. This is B cube. Take it as B cube. And this is like A is less than equal to B cube. This is the relation. How we can solve? See, if I take 2 comma 2, then 2 for 2 comma 2, is it true? 2 is less than 8, correct? Now, if I change their place, will it hold? Only for one of the number, not for all the set, all the values, correct? Only for 1 comma 1, 1 is less than 1. But again, this is not less than, this is just equal to 1. Okay. Why it is not symmetric? 2 comma 3, is it equal to 3 comma 2? Again, this is not equal because it is two comma 3 is what? 2 is less than equal to B as 3 to the power 2, 27. 3 comma 2, 3 is less than equal to 8. Now both are not the same thing, correct? So it is none of the following, that is none of the reflexivity, symmetric or transitive. Try to solve this problem. Anyone has any doubt? Please try to solve. Okay, let's see. If A minus B is even, so we can take it like 4 minus 2. So is it reflexive? Yes, 4 minus 4 is 0. 3 minus 3 is 0. So this is true. That is the reflexive part. What about the next one? So for this problem, it should be mod of A minus B should be even, correct? Should be like mod of A minus B should be even. Then only it will be equivalence relation, correct? So 4 minus 2 is 2. Then 2 minus 4 is also 2. Now, if 4 minus 2 is 2 and 6 minus 4 is 2, then I mean, what is the meaning of 2 here? Even. Even. This is A comma B. This is B comma C. What about A comma C? A comma C will be 6 minus 2. So what is 6 minus 2? That is also 4, which is even. So it is now transitive also, correct? So this is the example of symmetric.
Sir, if we are looking for only even, then if there is no modulus, then also it is equivalence relation, isn't it?
Actually, it is not, because -2 is not considered as an even number.
Okay.
Okay. So there is a very simple problem. Try to answer, everyone. Question number 7. People those who are watching on YouTube can also answer on YouTube chat. What is the answer? Please write down the answer in the chat, guys. So what is the domain for this? -1 to
-1, 1, -2, 2.
-1. Sorry, -2, -1, 1, 2. Correct. What is the range?
1, 4.
1, 4. Can you tell me, anyone, what will be the relation here? What is the relation here?
A square is equals to B. B is equals to A square.
A equal to B square or B square equal to A. Correct. B equal to A square is correct.
Yes.
If I write A comma B.
Yes.
What is the answer for this one? This is A cube. This is A comma A cube. Less than 5. Find the range of R.
$27.
A is a prime number less than 5.
27.
So A is a prime number less than 5. So what are the values? 2, 3, correct? So what will be the range?
8 and 27.
8 and 27. It is A cube, Sujan. Try to answer this question number 11 and question number 12, everyone. What is the answer? A is 1, 2, 3. So we have 1, 1, 2, 2, 3, 3, correct? So it is reflexive. We have 1, 1, 2, 2, 3, 3. So this is obviously reflexive. Now we have to find 1, 2. This is 1, 2, 3. So do we have 1, 2? Yes, Dipesh, we'll solve that, but we'll solve after some time. Okay. Let's solve these two problems. There are many questions on this, so don't worry about that. So is it reflexive? So what is reflexive? A, B should be BA, correct? Means if I write 1, 2, so I should get 2, 1 also. It is not reflexive, correct? Sorry, it is not symmetric. 1, 2 is there, but 2, 1 is not there. So it is not symmetric. So if it is not symmetric, this is not true, this is not true, this is not true. So what is the answer? Option B. In this, do we have 2, 1? 1, 2 we have, but do we have 2, 1? We don't have 2, 1. So obviously it is not symmetric. Are you getting it, guys? So let's see 12th, what is the answer? See, it is AA is there. So here we have like AA is there, but we don't have BB. Even if I take another element, I should get BB, then only it will be reflexive, correct? So it is not reflexive. So answer should be C. Anyone has any doubt? Very good. Many of you have given the correct answer. It is C. Any doubt, anyone? So now we are coming to the major part of relation and function. Now we have entered into function, the major part of function, to find the domain and range. What is the range for this function? What is the range for this function? So how to find the range of this function? That is a function which is under root. If a function is under root, so first thing is 9 minus x square should be greater than or equal to 0, correct? 9 minus x square should be greater than or equal to 0. So what about x square now? So 9 minus x square is 3 minus x, 3 plus x should be greater than equal to 0. So if I take it like this, so this is 3 minus x should be greater than equal to 0. 3 plus x should be greater than equal to 0. So less than 3. So it should be less than, it should be greater than, x should be greater than minus 3, correct? If I take 3, if I take minus 3 this side, it will become what? X is greater than minus 3. So what is the range? X is greater than minus 3 and less than 3.
Domain, not range.
So what is the answer for this problem? It belongs to minus 3 to 3.
A.
So answer is option A, minus 3 to 3. Have you solved this kind of problems earlier, guys?
Yes, sir.
Yes, sir.
Many times.
This kind of questions you have seen. Then try to solve this one. What is the answer? What is the answer for this problem, guys?
D number.
So if this is true, means what? X minus 1, x minus 4 should be greater than equal to 0, correct? Also, x minus 4 should be, can't be x minus 4 can't be,
0.
it can't be equal to 0, correct? So these are the two conditions which we are getting it here. Now to make this one greater than or equal to 0, so x minus 1 should be greater than 0, correct? As well as x can't be equal to 4. Now, if x is not equal to 4, if x is not equal to 4, this option is ruled out. Why? Why do we say that? Because it is 4 big bracket. What do you mean by this? What do you mean by this?
A and B both are included and middle
B
points
both are included and all the
middle points.
real numbers between them is included, correct?
Yes.
What is the meaning of this?
A is included, but B is not included.
Excluding B.
What is the meaning of this?
A and B both are not included, but between them real number are included.
What is the meaning of this?
3 is excluded from the
Is
real number.
excluded from real number.
Means all the real numbers are there except 3.
Except 3.
3.
Except 3, we have to use all the real number, that is the range, correct? So here 4 is not included. If 4 is not included, then option C and option B is ruled out, correct? Because here they are saying that 4 is included, correct? Now we have x should be greater than or equal to 1. If x is greater than 1, also x minus 4 should be greater than equal to 0. Then only both are positive, then only it will be positive, correct? If
Yes, sir.
numerator is positive and denominator is positive, then only we'll get the entire value as positive. So this is what x should be greater than equal to 4.
Not equals to x. X should be only greater than 4, isn't it?
No, sir.
Yeah, tell me.
X should be always greater than 4 then. Because already we have mentioned x minus 4 must not be equals to 0, our condition, initial condition.
If I include this too, I can say that x should be always greater than 4, correct?
Yes, sir.
If you include this, x should be always greater than 4. But what if both of them are negative? See, one case 1, we have taken 2 cases, correct? Are you getting it?
Yes, sir.
So I'll just do it once again. So case 1, if x minus 1 is greater than 0 and if x minus 4 is greater than 0. So from here what we are getting, x should be greater than equal to 4, correct?
Yes, sir.
Case 2, x minus 1 can be less than equal to 0, x minus 4 should be less than equal to 0. So from here, what we are getting? X should be less than equal to 1, correct? Yes or no?
Yes, sir.
In both the cases, we'll get it. Another case we have. What is the another case? X minus 4 can't be equal to 0. So X can't be equal to 4. So these are the three cases which we have to combine. So using this, all the values which is greater than 4 is the answer. For this, all the values which is less than 1 is the answer, correct? Now in this case, this is closed and here it is open, correct?
Yes, sir.
4 is not included, 1 is included. So which answer is correct? This is written as minus infinity to 1. 1 is included, union. 4 is not included to infinity, correct? Infinity is always open bracket. Are you getting it, guys?
Yes, sir.
Anyone has got any doubt?
No doubt. Everything is clear.
Try to solve this one. Manjeet, I hope you know that, exam date and all will be announced by the Embassy of India in the Nepal, correct? So you may get this information directly on the Google. You know the same as we know about the exam dates. Correct, guys? So please ask questions related to this topic, okay? Manjeet?
Okay, sir. Okay, sir. Sir,
So what is the answer? Yeah, guys.
I didn't get it.
What is the answer for this question, guys? Dipesh and Gautam has given the answer. Let's see. See, x square minus 1, x square minus 1 can't be negative, correct? So this should be greater than equal to 0. Also, x minus 1 should be greater than 1, greater than 0. Log function can't be negative. It can't be equal to 0 also. So it has to be greater than 1. So case 1, this is case 2. So what is this? X minus 1 and x plus 1 greater than equal to 0. So what is this? X is less than 1, greater than in between minus 1 to 1. Sorry, my mistake. So from here, what we are getting? This is 1, this is minus 1, this is 1. So we can take any value which is greater than 1 or less than 1, correct? Now, if I take this case 2, what is case 2? X should be greater than 1, correct? X should be greater than 1 means we have to take only this option. Do we have to include 1? No, we don't have to include 1. So answer is option C. Did you understand, Manjeet?
Yes, sir.
Anyone has got any doubt? Guys, do you have any doubt? Try to solve the next one, question number 4. The answer? So here we can say like x square minus 1 can't be equal to 0, correct?
Yes, sir.
So x square can't be equal to 1. So x can't be equal to +1 or -1, correct? So answer is option D, r minus -1 and 1. Because we just have to take the denominator part. Anyone has got any doubt? Try to solve this one, guys. Question number 5. I'm expecting everyone to answer this question.
Sir, answer C.
So let's see. See, minus in, sorry, sine inverse x. Sine inverse x, what is their range? -1 to 1, correct? But from -1 to 1, can it be 0? Is it possible to take 0? Because of denominator, we don't want 0, correct? So what is the answer? Option C. So those who have given the answer of option C, your answers are correct. That is Sujan, Ritik, Samir, Gautam, Dinesh, everyone has given the correct answer. Very good, guys. Try to solve this one. Question number 6.
Sir, answer B.
Hello, sir.
Yes. B is the correct answer. Where it is -1 to 1, but -1 to 1 is just for x. So for 2x, what is the answer? Divide by 2. So answer is -1/2 to 1/2. Try to solve question number 7.
B, sir.
So again, it is cos inverse this. So cos inverse this is like 3x minus 1. The range is -1 to 1. So if I take it as 3x minus 1 as -1, so and 3x minus 1 as 1. So x will become 0. And here x will become 2/3. So what is the answer again? Option B, 0 to 2/3. Okay, guys. Anyone has got any doubt? Try to solve this.
Answer is C, sir.
What is the answer?
C.
C is correct. So this is like question number 10 and 11. 2 questions are there. What is the answer?
None of these. Last D answer. D and D.
Question number 10. Log 2x minus x square should be greater than or equal to 0. Now 2x minus x square should be greater than 0, correct? Okay. So here, what is there? So 2x minus x square should be greater than equal to 1. So x, if I take common, it is like 2 minus x should be greater than 0. So x should be greater than 0. X is less than 2. So what we are getting it here, x square minus 2x plus 1 should be less than equal to 0. So x minus 1 whole square should be less than equal to 0. X should be less than equal to 1. So we'll combine this 3. X is less than 1. So if this is 1, x is less than 1 is from here to here. X is less than 2. So if this is 2, x is less than 2. X is greater than 0. So x is greater than 0 goes from here to here, correct? So what part is common here? So what part is common here?
Zero comma 2.
0, 1 is common, correct? Let's see. If I put x as hello. Please put your mic on mute, guys. If you put x as 1.5, let's suppose, what will be getting? This will become 3 minus 1.5. 3 minus 1.5 square is 2.25. That is positive, correct?
Sir,
This gives us both the values, correct? X is less than equal to 1 or x is greater than equal to 1, correct? So ranges from here to here. So answer is 0, 2. What about question number 11? Guys, please, Gautam.
Gautam.
What about question number 11? See, domain will be all the real numbers, correct? And range will be all the positive numbers, correct? So answer is option C. So question number 11, answer is option C. Any doubt, anyone?
No doubt, sir.
Try to solve this question number 11. Sorry, this is the same problem. This is x cube. Question number 9 once more.
In place of 10, there should be 9, I think.
Question number 9 was not there only.
Yes, sir. I think that was.
That's the reason he's asking the pace. (8)(1) root cos theta 1. See, what is the range of cos x? Minus pi by 2 to pi by 2. Cos 90 is 0. So what? Root under 0 is valid. Root under 0 is equal to 0. That is valid. Dipesh. So instead of 9, I have done it like this is 10, this is 9, this is 10, this is 11. Okay. Try to solve this one. Question number 11. What is the answer of question number 11? Option A is correct because it takes all the roots, all the values. The graph is like this, correct? This is the graph of x to the power odd. This is the graph of x to the power even. So what is the range of x to the power odd? Range is all the values on the y-axis. And domain is all the values on the x-axis, correct? So what is the domain? What is the domain of this? If it is x to the power even, domain is all the real numbers. And range, what is the range? Range is only positive real numbers. Okay, guys. And this is the graph of x to the power 1/2. Try to solve question number 12. So what is the answer? See, log 1 minus x. So 1 minus x should be greater than 0. Root x square minus 1. So x square minus 1 should be greater than equal to 0, correct? So greater than x is less than 1. X is
X is greater than or equal to 1 or x is less than or equal to 1.
is either greater than or equal to 1 or x is less than or equal to 1, correct? So in this two, what is combined? If you combine what we are getting, x is less than 1, correct? Not even equal to. X is less than 1 is the answer, correct? So x is less than 1. X is less than 1, but it can't be equal to 0, correct? If I put 0 here, it will become minus. So it can't be 0. So it should be x is less than 0 is the final answer, correct? What we are doing here. See once again. For this one, what should be the range? Sorry, domain. What will be the domain of this? X square minus 1. X square minus 1 should be greater than or equal to 0. So what is the range here? So x minus 1, x plus 1 greater than equal to 0. X is greater than 1 or x is less than minus 1. So x is greater than minus 1, less than 1. Now C is not true. See, if you take C, means what? I am considering 0 also, correct? If x is 0, this equation won't work. So C is not true. One or greater than 1. Let's suppose 2, 1 minus 2. So even this doesn't work. Including minus 1. So if I include minus 1, this will become 1. This will become 1 minus 1. That is correct. Minus 2 if I put. So this is also, you can, this is how you can solve the problem if the options are also given. So let's see how we can solve directly using the option. So I'll consider it as, let's suppose this one. Let's suppose this one. So in this we have 0. I can't put 0, correct? So this can't be the answer. Minus 1 to 1, we have to get minus 1, 0, 1. So this equation Both the equations should be true on all these three values, but it is not true on 0. So option C is ruled out. I can't put 1, or I can't put anything greater than 1. For this, obviously the answer is less than, x is obviously less than 1, correct? X is always less than 1. So less than 1, this is not true. If I take any value between 0 to 1, let's suppose I take 1 by 2. 1 by 2 is square minus 1. 1 by 2 square is 1 by 4. 1 by 4 minus 1 is minus 3 by 4. So again, this is not true. So what is the true answer? Minus infinity to minus 1. Are you liking this method? Directly solving using options?
Yes, sir.
Sir,
Those who are liking this method, directly solving using option, please write down yes in the chat. Write down yes in the chat.
yes,
Let's
sir.
see.
Yes, sir.
Write down. Try to solve this. We know that minus 1 to minus x square should not be equal to 0, correct? So x can't be equal to minus 1 or 1, correct? So what is the answer? Real number, all the real number minus 1 to 1. So answer of this question is option D, none of these. Now using option also, if you want, you can check. If I take 1, it will be 1 minus 1, 0. If I take 1, again 1 minus 1 is 0. If I take 1, 1 minus 1 is 0. So in all the three cases, all the three options are not correct. So what is the correct answer then? None of these. Correct, guys? Try to solve this question number 14. They want range. Keep that in mind. Okay, sorry guys. Here we had to find range, not the domain. We have to find the range of this function, correct? So y equal to 1 divided by 1 minus x square. So 1 minus x square equal to 1 by y. X square equal to 1 minus 1 by y. X equal to y minus 1 by y, correct? So y can't be equal to 0. So we have to find the range, not the domain. So we'll again check the value. Question number 13. It can take the value as 1. It won't take the value as minus 1. No, it can take value as minus 1 also. It can't take 0. So y minus 1 should be greater than or equal to 0. So y should be greater than or equal to 1. Option B is correct. So what was the domain of this function? All the real numbers minus 1 to 1, minus 1 and 1. And what is the domain? Sorry, what is the range of this function? Option B, that is 1 to infinity. Anyone has got any doubt? Try to solve question number 14. You have to find range. So y equal to x square, 1 plus x square. So here we'll take it as like y plus y x square equal to x square, correct? So y equal to x square 1 minus y. So x square equal to y divided by 1 minus y. So what is x equal to? Root under y divided by 1 minus y. 1 minus y can't be equal to 0. So here 1 minus y can't be equal to 0. So y can't be equal to 1. So if y can't be equal to 1, all these options are ruled out. So only one option is remaining. If y can't be equal to 1, correct? Y can't be equal to 1, then all these options has 1, correct? Including 1. So that's the reason answer becomes 0 to 1. Excluding 1. Anyone has got any doubt? Guys, do you have any doubt?
Clear, sir.
Last question. Last question for the day. You have to find the range of this. This is the graph of this function. X plus 1 by x graph looks like this. To add x as 1, this is minus 2. At x as minus 1, it is minus 2. And at x as 1, this is 2. So what is the answer here? What is the range? Range is minus 2 to minus infinity to 2. So anything here is the range, correct? So minus infinity to 2, including 2, union 2 to infinity. So what is the answer for this question? Minus infinity to 2, minus infinity to minus 2, union 2 to infinity. The answer is option D, none of these. This is the graph of this function. X plus 1 by x graph. So all the values on the y-axis above 2 is valid. All the values on y-axis below minus 2 is valid. So answer is minus infinity to minus 2, 2 to infinity. Okay. So here what they have done, see, 2 to infinity minus infinity to minus 2. So answer should be union of these two. So instead of that, they've given it as a 2 different options. That's the reason answer becomes none of these. Any doubt, anyone? Guys, do you have got any doubt?
No doubt, sir.
So we'll wind up today's class here. We'll meet with maths class day after tomorrow once again. Tomorrow you will be having chemistry class at the same time, 4:30. I hope you guys have got the timetable and all.
Yes, sir.
Any? Okay, so thank you everyone. Thank you guys. Thank you, Sujan. Thank you, Gautam. Thank you, Dipesh. Thank you, Manjeet. Good night, Sujan. Good night, Dipesh. Good night, Ritik. Thank you, Ritik. Good night, Manjeet.